Name is Jack Horsfall, and today I'll be talking about the Microwave Landing System, commonly known as MLS. This presentation covers what MLS is, how it works, and why it was developed as an alternative to traditional landing systems in aviation. So, to introduce it, since the 1930s, aircraft have used the Instrument Landing System, or ILS, to land in low visibility conditions. ILS uses radio signals to guide the aircraft along the correct lateral and vertical path during the approach. It is accurate enough to bring an aircraft down very close to the runway, even without visual contact. But as aviation technologies advanced, new systems were developed to improve precision and flexibility. One of these systems is the Microwave Landing System, which emerged in recent decades. So just continuing, like the ILS, the MLS provides accurate position and information relative to the runway. However, the key difference is the frequency band it uses. Instead of operating around 109 to 331 megahertz, an MLS uses a band of just over 5 gigahertz. This high frequency allows MLS to deliver its main benefits, provide precision guidance down to Category 3, including autoland and support for complex approach patterns used in both civil and military aviation. In other words, MLS can guide an aircraft very accurately and can support approaches that aren't straight in, such as curved or offset approaches. So on this slide, we've just got a short video explaining how MLS works. MLS transmit a time reference scanning beam in both azimuth and elevation. The aircraft receives these signals and calculates its position relative to the runway and displays guidance to the flight crew or autopilot. So just watch that. We have to watch with subtitles because unfortunately it won't record audio. Just a quick advert. Oh, love it. Right, so as the video said, the MLS has several important features and technical advantages. So it supports 200 channels worldwide, which avoids frequency congestion. The azimuth coverage is at least plus or minus 40 degrees from the runway heading to give it a large coverage. The glide slope angle can be selected anywhere between 0.9 and 20 degrees, offering a wide range of approach profiles. And the usable range is 20 to 30 nautical miles, depending on the country. It operates between 5031 and 5090 megahertz in the super high frequency band. Using a higher frequency means MLS can be installed in hilly or uneven terrain without needing a perfectly level site. Also avoids errors caused by buildings, vehicles, or aircraft in the signal path, which is sometimes a limitation with ILS. And because of the wider coverage, MLS enables aircraft to choose different approach paths, increase runway capacity, and offer benefits to helicopters and short takeoff aircraft, something ILS often struggles with. The US, so examples of it being used in the US, the government identified several complex approaches where MLS could dramatically improve safety and access in poor weather conditions. There's some examples, like it says on the screen, include the river approach at Washington National Airport, the Canarsie approach at JFK in New York, and the Quiet Bridge approach in San Francisco International. These are all curved or offset approaches where traditional ILS is difficult to use and would require expensive ground installations. MLS makes these types of approaches simpler and more reliable. So there's three components that makes up MLS. The azimuth transmitter, which gives horizontal guidance, the elevation transmitter, which gives vertical guidance, and the DME, distance measuring equipment, which gives distance measurements, obviously. Together, they allow the aircraft to calculate its position in three-dimensional space relative to the runway. MLS has several major advantages: very accurate and reliable guidance, more flexible approach paths, no signal distortion from nearby objects, and good performance even in difficult terrain. And also supports auto-land operations down to Category 3, making MLS a highly advanced system compared to the ILS. However, despite these advantages, MLS was not widely adopted. The main reason was cost. Installing MLS at airports was very expensive, especially at a time when satellite-based navigation systems like GPS and GNSS, Global Navigation Satellite Systems, were emerging. These systems offer similar precision without large ground installations, so as a result, MLS was largely replaced by Global Navigation Satellite Systems based approaches, which are now common worldwide. So to summarize, MLS was designed to improve landing accuracy and provide flexible approach paths that ILS couldn't support. It offered excellent technical performance, especially in complex terrain or curved approaches. However, due to the cost of installation and the rise of satellite-based navigation, MLS was never widely implemented and has mostly been replaced by modern GNSS systems. Thank you for listening.